Today we are going to discuss using the sine rule to find the length of a side in a non-right angled triangle. So starting point is, what is the sine rule? The sine rule is the relationship between all three angles and all three sides of a triangle. And what sine rule says, if we label our triangle first of all, we've got angle A here, so side A is here. We've got angle B, so side B is here, and then we've got angle C, so side C is here. And what sine rule says is that side A divided by sine of angle A is equal to the same value as side B divided by sine of angle B, and that's also equal to side C divided by sine of angle C. Okay, and at any given point, if you're doing one of these calculations, you will in fact only be using two of these fractions, but it's important to note that all three of them are in fact equal. And again, this is not a formula you'll need to remember, you will be given it in the exam. So how do we use it in practice? Okay, so we have a diagram showing a triangular shaped garden, and a jogger runs from one corner of the garden to the other as shown. Calculate how far he has run. Okay, so what I want to show is that I have A over sine A equal to B over sine B equal to C over sine C. And at least one of those fractions needs to be complete, and we need to have the other piece of information and the missing piece of information on another fraction. So if I label this A, B, C, this is angle A, so that's side A, this is angle B, so that's side B, and this is angle C, so that's side C. If I go through this, I have side C and I have angle C, so there's my complete fraction. I have angle B, and then I'm looking for side B because they want to know the distance, so there's my other fraction. So I can basically pretend that A over sine A doesn't exist. And then now what I do is I just substitute in my values. So this B is what I'm trying to find, and then sine B, so if I look at angle B, that's sine of 50, and that's equal to side C, which is 65, divided by sine of angle C, so sine of 100. Okay, so by using all of the same techniques that we've learned for solving equations, here I am dividing by sine of 50. So if I want to pretend that sine of 50 never happened to B, I'm going to have to multiply by it. So B is going to be equal to 65 times sine of 50 divided by sine of 100. And when you put this in the calculator, you need to make sure that you're closing the brackets around those angles. Otherwise, this is not going to work in your calculators. And then if I do that, I end up with 50.56 meters. So he has run 50.56 meters. Okay, so that first example was a very basic example where you were given all of the information that you needed. Let's take a look at another example where maybe you don't have all of the information. So again, we're still going to go with that A, B, C. So this is side A, this is side B, and this is side C. And I have A over sine A equals B over sine B equals C over sine C. Okay, so two wires holding a flagpole are fastened at the same point on the flagpole, and 2 points on the ground are 12 meters apart. So A and B, this side here, are 12 meters apart. The longer wire is frayed and has to be replaced. What length of wire must be bought? So that means the longer wire is this one here, so I'm finding B. So let's go through this. Okay, I have angle A, but I don't want to know anything about A. I have angle B, and I want to find out about B. I have length C, but I don't have angle C, but I do have a means of finding that out. All three angles in a triangle will add up to 180 degrees. So if I do 180 minus 48 plus 65, I will get that that angle C is 67 degrees. So here is here is 67 degrees. So I do in fact have sine C. So again, I can pretend that sine A over sine A never happened. So I now have B over sine B equals C over sine C. And if I fill in my information, I've got my missing side, so I'm just going to keep calling it B, over sine B, which is sine 65, equals C, which is 12, over sine of 67. And again, I'm dividing by sine 65 here, so to pretend like it never happened, I'm going to have to multiply, so I'm going to have B equals 12 times sine 65 divided by sine of 67. And if I can squeeze the answer in here, that angle is 11.81 meters. And my final example here, a diagram shows the relative positions of a church, a statue, and a flagpole at the corners of a park. Calculate the distance from the church to the statue. So that means that I'm going to be looking for this part here. Okay, so let's label A, B, and C. Okay, so A over sine A equals B over sine B equals C over sine C. Okay, so now if we compare our information, we will see that we have angle B, angle C, and then we're missing side A. We don't have any information about side B, and we have side C. So sine C, C over sine C is our complete fraction. Because we're wanting side A, we need the angle sine A. And that's just a repeat of the same calculation we did last time, where you total up the two angles that you have and take it away from 180. So that's 180 minus 50 plus 64, and that means that angle A is in fact 66 degrees. Now we've got enough information that we can go and complete this question. So we've got A over sine 66 equals 210 over sine of 50. And then again, like before, we're dividing by sine 66, so I'm going to multiply by it now. So 210 times sine 66, all divided by sine 50, and therefore the length, the distance between the church and the statue is 250.44 meters. Okay, so now we're going to take a look at part B. Part B was about finding the length of the area covered. And we now have that this is 250.44. This angle here is 64. And then the length of the other side is 210 meters. So we now have enough information to do area equals half AB sine C. So area is equal to half of 210 times 250.44 times sine 64. And if we carry out that calculation, we will get 23,634.87 meters squared.